So now that we can put together an equilibrium expression for a reaction, we're going to start using data to actually calculate some things. We're going to do two types of problems in this video. The first of which, we're going to look at a reaction where we're at equilibrium already. We know the equilibrium concentrations, and what we're being asked to find is the value of the equilibrium constant. I always like to start any of these problems by first actually writing the equilibrium expression. So it's always products over reactants. You do need to raise it to the coefficient, but in this particular case, the coefficients are all one. So it does not impact the equilibrium expression. It is also a homogeneous expression, meaning we can include everything. Everything's a gas. So now, if I want to calculate that equilibrium constant, the value of K, I'm going to start plugging in for everything my molarities. It's important that they are molarities. So you want to look for a capital M or moles per liter for each one of these. If it's just moles, you need to find the molarity first. We're lucky. In this case, we're given the molarities. So for NH3, I'm going to plug in 0.518. And for CO, I'm plugging in the same value, 0.518. And for the value for my reactant HCO and H2, I have 0.0637. And I'm going to calculate my value now of K. So in my calculator, I say 0.0 or 0.518 times 0.518 divided by 0.0637, and I get an answer of 4.2. 4.2 does not actually include any units. Traditionally, equilibrium constants are written without units. That's an important thing to know. There's also something important to know about that value. Anytime that K is greater than 1, we would say that essentially we have a reaction in which we have products that are favored. Let's talk about what that means. To say that the reaction favors products just means essentially that we have more products than we have reactants when we reach equilibrium. If it were less than 1, then that would imply that we have more reactants than we do products. Okay, just an important thing as we move forward. We'll come back in a few minutes and we'll practice another one on this next slide. But for now, let's do something else. What if we were asked to use a known value for the equilibrium constant to calculate an unknown concentration? And again, we're going to do this such that we are only going to do one of them. We'll do A, and we'll come back and we'll do something like B or C. Okay, so I'm going to set up my equilibrium expression first. This is homogeneous or homogeneous equilibrium. It's products over reactants. I do need to raise them to their coefficient. So H2 is raised to the third power. C2H2 is raised to the first power. And I'm going to place that over CH4. So we're going to see, and that's going to be raised to second power. We're going to see Mr. Lyle's calculation skills because I don't have my scientific calculator with me, and I should, but we're going to need it in this case. They tell us that we have a K value. I don't know why that happened. they tell us we have a K value of 0.118. This is a reaction that clearly favors reactants because the K value is less than 1. H2 is given to us. It's 0.373, and we're going to cube that. The C2H2 value is given to us. It is 0.0812, one of my favorite numbers of all time. And we're dividing that by an unknown concentration, CH4, which we're going to call X squared. Okay? I'm going to rearrange this, and I'm going to run out of space. I'm going to do a couple things at the same time. I'm going to bring, let's change my color so we can see this. I'm going to bring X squared up here, and I'm going to bring 0.8118 down there, or 0.118, sorry. So that's going to give me X squared equals 0.373 cubed times 0.0812, great number, over 0.118. Okay, so X squared, let's do the math on that, is going to be 0.373 cubed, having to do this the long way, times 0.0812 divided by 0.118. You do the math on that, you get X squared is equal to 0.0357. So if I take the square root of that, X is the square root of 0.0357. Let's see if we can do that. I get 0.189. Now I am going to put a unit on that. I'm going to put a capital M for molar. Moles per liter is fine as well. And why? Because this is equal to the concentration of CH4. We're going to come back and we'll do a problem similar to that as well. We'll see you in just a couple of moments.